So like I said, we're going to still be simplifying exponential expressions. And again, we want to leave them in all positive, but we might have some radicals mixed in here that we have to convert first, which is kind of mixing the two together. So another thing that you're going to have to do is also in problems like this and this, find the missing piece using your exponent rules. So we're still simplifying, but we're also taking it in a few different ways. Okay, so if we look at something like number 1, it's saying 4 to the 2/3 times 4 to what power gives you 4? So what is the exponent of our answer if it's just 4? It's a 1. So what do we do to the exponents here to try to get 1? Anyone remember what the property tells us to do? Chase? Good. When we are multiplying like bases, we add the exponents. So that means 2/3 plus what gives us 1? Because this is our x, what we don't know. But we know that they have to add up to equal 1. So when you subtract 2/3 from both sides, what do you get? So then x, or that space, would equal 1/3. So if we take that same idea and go look at number 2, we're given 4 to the 1/4 times 4 to the 2/4 equals 4 to the x over 4. So again, we want to think about what do we have to do to these exponents to get x over 4? Add them together. So 1/4 plus 2/4 equals x over 4. So what is 1/4 plus 2/4? 3/4. So what does x have to equal for this to be true? X would have to equal 3. So it's taking your exponent rules and kind of using the exponents to set up an equation from just the exponents instead of the whole term as a whole. Okay, any questions so far? Okay, so then if we look at number 3, we have the 4th root of 5 to the 3rd times the 4th root of 5 to the 6th equals 5 to the x over 4 power. So when we have different formats, what should we do? Get them all to be the same. So I'm going to convert all of them to exponential. So this will become 5 to the 3/4, 5 to the 6/4 equals 5 to the x over 4. So now it looks just like number 2. It started off looking like a radical. Now it looks just like number 2. So again, we're multiplying like bases, so the exponents get added together. So 3/4 plus 6/4 would have to equal our final answer exponent of x over 4. So 3 plus 6 is 9. So 9/4 equals x over 4. So what does x have to equal? 9. Okay, any question on those type? Because that's kind of a little different, but you do have quite a few on your assignment today that are like that, where you're finding the missing piece of your expression. Okay. The rest of your assignment, after you go through and do some like this, you're just going to do some more practice with simplifying. So here we have number 4. And what I would suggest is that you look inside your parentheses. See if you can simplify that first before we go and put our -4 through. So can we simplify what's in parentheses? Anyone? Yeah, because we have an m to the 4th on top and an m squared on the bottom. So that means we can make it 4 minus 2, so that'll give me 2m squared, and we no longer have a denominator. Now we can put that negative 4 through to both terms, so 2 to the negative 4, m to the negative 8, because we have a power to a power, so we're going to multiply. Now we can go ahead and take the terms that have negative exponents, which is all of them, and move them to the denominator, so 2 to the 4th, m to the 8th. And then last step would be figure out what is 2 to the 4th. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16m to the 8th on the bottom would be your final answer. Yeah.
So on the bottom there wouldn't even be an m, just for empty.
No, because when we combine these m's by subtracting the exponents, so 4 minus 2 gave us positive 2. So we ended up not having any left to go down to be on the bottom. They all moved up to the top. Max?
When it's a fraction, do you have to put it back in a fraction?
Not unless it requires. Like this required us to go back to a fraction because we ended up with negative exponents. If this wasn't a negative exponent, our answer would not have been a fraction. So it kind of, the problem will tell you, might lead you back to a fraction, but not always. Okay, so then if we look at something like number 5, where again we have a combination of exponents and radicals. So again, we want to try to get everything into the same format, which usually is going to be exponential because we have a ton of exponential rules that we can use. So 8 to the 7/3 will stay exponential, and on the bottom we'll do 8 to the 4/6. So we're going to need to reduce 4/6 here on the bottom, so that way we get a common denominator with our top. So what is 4 divided by 6? 2/3. So we'll have 8 to the 7/3 over 8 to the 2/3. Because it's division, we're going to subtract the exponents. So we'll have 7/3 minus 2/3. So what's 7/3 minus 2/3? 5/3. So then, let's see. Let me double check your direction. Yeah, we're leaving all of our answers in exponential. So we want to leave it here because your directions are going to say write the final answer using only positive exponents. Okay, any questions on that one where we had both formats in one problem? Okay, then the last one here, number 6, has a lot of parts to it, so we're just going to take it a piece at a time. So if we start with the 6x to the 1/3 squared, let's put that 2 through to both terms. So we'll have 6 squared, and here we have a power to a power, so that's 2/3. And then over here we don't have any exponents on the outside, so I'm just going to drop the parentheses and do 2 times x to the 5/3. On the bottom, I'm going to go 8 to the 1/3 times x to the 1/3. So I'm going to work just the numerator right now. 6 squared. Anyone know what 6 squared is? 36. So I'm going to write 36 over here. So now I can multiply 36 times 2. So 36 times 2, I believe, is 72. And then we can add the exponents of our x. 2 over 3 plus 5 over 3 will give us 7 over 3. Then we can work just with our denominator. Now 8 to the 1/3. I'm actually going to go and write that as a radical because I can simplify it if it's a radical. Whoops. Not 2, 8. So if we break this down, 2 and 4, 2 and 2, do we have a group of 3 things? Yeah, we have 3 2's. So I can rewrite this 8 to the 1/3 as just 2. And then I still have my x to the 1/3. So sometimes if you have a fractional exponent on a number, it's helpful to change it to radical to see if you can reduce it. So from here, we can divide the numbers. So 72 divided by 2 is 36. And for the variable, we can subtract the exponents. So 7/3 minus 1/3, 6/3, which we can rewrite or reduce to be 36x squared. And that would be your final answer.
And so how did you get the 36?
72 divided by 2. So just divide the numbers like we would normally do it. And so just to kind of reiterate, we only subtract exponents with division, not the numbers themselves. Coefficients will still act like normal division. It's only the exponents that have the subtraction rule to it. Okay, so your assignment for today is kind of going to be a lot more problems like 4, 5, and 6 that have a lot more properties with them. Is there more than just the one way to do it? Yeah, so like how Rosemary did hers a little differently from the homework, you might be able to go a different path, do different orders of things, but your answers should still come out to the same. And then again, you're going to have some that look like 1, 2, and 3 where you're finding the missing piece to the equation. So are there any questions that you have on anything?